All right. Hello, my name is Martin Freegard, and today I'm going to be presenting. This is actually the second presentation for cleaning data with OpenRefine. This is going to be a little bit different than the last section. I used a 538 data set from their GitHub account. We're actually going to be going through some different web technologies, so it's going to be a little bit more advanced, but it's actually going to just take a little bit of a left turn, so that way you get a kind of a broader exposure to what OpenRefine is capable of doing, and the different ways you can take an existing data set and enrich it with what are known as APIs. So once again, first steps: make sure you go to the openrefine.org and download the application. It'll come in either an exe file or a DMG. You'll download it, and when it opens, it actually opens directly into your web browser. We'll go through some of the interface when we get into the actual case study. But the first things we're going to talk about are just these web technologies that are, non-rectangular, meaning it's not a spreadsheet data objects. We're going to talk about how you basically get those data objects into something that you can feed into a statistical software or a visualization software, so that you can make either an application, a dashboard, or just a visualization or a map for your article. How you can make these things reproducible, how you can script them, and then of course how you can share your work. The reality is, now that the internet kind of collects data on so many different attributes, it's really that there's just an endless amount of data out there. There are, numerical data is the obvious one, but there's text, there's pictures, there's audio, there's video, facial recognition software. The amount of information that you can capture and that is captured today is amazing. And the only thing that's kind of limiting your ability to visualize it or use it to tell a story is your ability to access it. And APIs are one example of these larger tech companies, and really some of these more altruistic type endeavors, getting you access to some of these data sources that were previously just almost unthinkable. So data cleaning, and data janitor, isn't really the sexiest term. And in terms of data science, that's probably the one that's going to get you the most traction in terms of what the kind of the best job of the 21st century is. But I think that in reality, we spend most of our time doing this kind of work. Data visualization and data modeling, or any kind of statistical forecasting is going to require data to be in a particular shape, meaning it's going to be in columns and rows most of the time, and it's rare. There are times that you will analyze it in something else, but most of the time, statistical softwares, they're built to take data in a particular rectangular format, and you'll spend a lot of time getting it into that particular format. So we're going to go through just some basic data file types and structures that you're going to encounter whenever you're using the internet to enrich your data sources. So if somebody sent you a data file that was like an Excel file or a CSV file, we're going to go through the different ways that you can make sure that that's that data that you have is both accurate, but then it's also, if there's another piece of information that you can join to that, or you can enrich that information with, you want to be able to do that. The first couple examples are probably common or recognizable to everyone. Somebody just sends you a data in an Excel file or a CSV file. It's probably the most common. Somebody says, hey, here's some data that I have on housing costs in a particular area. Here's the data I have on your sports teams, or whatever the topic is. They're going to send you some data and say, see what you can get me out of this. Probably second most common, at least in terms of what I was doing, you're given kind of this login for a desktop, like on a remote server, that's giving you access to a database. And just because there's so much data, it'd be very hard to keep in like an email file. You can't put it in a single Excel sheet. So you're going to log in and you're going to access this data via a database system. Usually it's a relational database system. So it's either MySQL or Microsoft SQL Server or Postgres, but you're going to write some code. You're going to get some rectangular data out of it. and then you're going to take that data usually into your desktop or into your own remote space, and then you're going to run any kind of visualization or statistical analysis on that. The other one are just data that are available in continuous streams. So like web traffic or like Twitter streams and that kind of stuff. This is just a very high volume data source. It's not likely that you'll have a lot of interaction with this. Most of the time, this is more of a data engineering kind of interface. Most of it is just where do we store this data and how do we keep track of it. A lot of that is just for our that's where you run into these terms like a data lake, right, or a data warehouse. Most of the time that stuff needs to be cleaned and reformatted into a way to even put it into a SQL server or a relational database, but it's just another way that you could potentially interact with internet data or really web technologies. The final is the API, the application programming interface. This is when someone has basically given you like a port, or like a hose to basically come up, attach your nozzle right to like the end of their spigot and basically pull some of the data from their data source into whatever it is you're using. APIs are great because we can enrich current data sets with existing data that they've made available through these technologies. It all kind of moves through the internet, so we're going to talk about some other just basic files you're going to encounter on the internet. The first is just to know the difference between what is a plain text file, what is a binary file. I apologize if this is kind of preaching the choir or redundant to people who already know this, but I'll make it hopefully brief and useful. A text file is basically something that it can both be read by a human and a computer. So if you're writing a text file, that means that you can open it with like Sublime Text, Notepad, TextEdit. So it's plain text, meaning that the computer can read it if it's code, and you can read it if it's just plain English. These files are how you're going to interact with the command line. These are files that a lot of basic web pages are built with: HTML, XML. MySQL is an open source plain text kind of scripting language. Obviously there's like a bunch of different dialects for SQL, so some of it is going to work on more proprietary systems. Python is an example of an open source statistical software or really kind of general purpose computer programming language. Plain text, the .txt, you've probably seen that before. It's just kind of a plain text file. There's a very minimal formatting. A lot of times you'll see the monospace font, so it looks like a typewriter. Markdown is kind of this interaction between a human readable language that then gets easily converted to HTML. And then these first two that I listed here, XML and JSON, these are actually used to store data objects, which is what we're going to be talking about today. So these are all examples of plain text files. Most of them are built on the backs of open source technologies. Binary files, first to that, is it's usually attached to some proprietary software, and it's difficult for humans to read, but obviously software programs can read them and computers can read them. So this, of course, is the whole Microsoft suite of files and software applications. Word, Excel, PowerPoint. You have your compressed executables. So if you download a compressed file, it's been zipped into a certain format. You have zips and RARs. Most image data, even though you can kind of open it with anything, those are binary. So MP4s, JPEGs, GIFs, PNGs, these are all image data stored into a particular format that you can't, it's not, obviously it's very difficult to read text from an image data. You can use some of these, there are ways to render the information into a text editor, but it's certainly not human readable. You might be able to store it in that way, but you can't really interpret it or read it. So the reason I bring these two up is that most of the data API, most of the world of kind of internet data and internet technologies is plain text. And kind of the world of data science and really data analysis kind of is built around these plain text resources because it gives you access to the whole open source kind of universe of Python and R and SQL. And if you're building anything in the web, it's the HTML, it's the XML, it's the you're understanding kind of how these technologies work together in both an analysis way, but also in a rendering way. HTML is really great for like rendering text and formatted text and images. You know, XML and JSON are really great for storing data and attributes, right? We'll get into that a little bit more. So the reason that like rectangular files are so helpful is that we get this kind of intersection of columns and rows, right? So you can represent a distinct piece of information in a spreadsheet with columns and rows, or, you know, if you're a statistician, these are variables and observations, but they typically require some kind of software to open it. You can use OpenOffice, that's open source, but it's that one of the difficulties of dealing with rectangular files is that it's very hard to see all of it at one time. So a lot of times we want to be able to see our data in a table and kind of make sense of it, but there's sometimes when the data are so huge, it is very hard, you know, it's like you can't fit it all on the screen. The text would be too small, you have so many columns and so many rows, and it's kind of collected in a way that doesn't make it very clear what these data are representing. So rectangular files are great when the data are small, or when the data are, if you're looking at a subset of the data. It's difficult when it gets very kind of vast in terms of volume, but then also if there are a ton of columns or attributes, it's harder to know what you're looking at. So these non-rectangular files, the JSONs and the XMLs, are written to kind of aid in understanding how the internet's kind of storing some of these data in really what are called attributes. So JSON is a little bit newer. XML is a little bit older. You know, these are kind of the same idea that it's you're storing and transferring data, and the big thing is that you can kind of store some attributes about the data with the data. You'll see what I mean by like these key value pairs. Like you're getting kind of a name for something, and then of course like what the something is. These are JSON data objects. JSON, you can see like it has name John, age 30. So you're getting some attributes of the thing along with the thing. And the columns and rows, you can do similar, but certainly not to the degree that you can with JSON. So it's like it's storing data as a document, but then it's also easily transferred in terms of, you know, it can be kind of like drilled down to a single dimension of a rectangle. Here's XML, which is kind of the same idea. It has these tags, right? So it's transferring information, you know, kind of in the term here is like self-descriptive, meaning like if we look at this, we can see, you know, question, answer, right? So it's giving us where the question begins, where the question ends, where the answer begins, where the answer ends. You get these symbols that indicate what that particular thing is. This is, you know, commented out. This entire document is a quiz. It has some header information up here. So you're getting a lot of information that describes the data along with the data. And that's really the big bonus of the JSON and XML, is that non-rectangular data gives you this idea of, it doesn't have to fit in a table. Some things have more descriptive information than others. There's plain text information that, you know, kind of like a more sentence or paragraph structure that needs to accompany some pieces of information. So rather than constrain yourself to dealing with the only things that fit in a rectangle, these non-rectangular objects give you a little bit more flexibility. All right, why bother? I kind of just gave the spiel, right? It's because there's just a little bit more flexibility. Again, relational databases also take up a ton of resources in terms of memory because you have to query them, and it's this kind of, you know, complicated computation device. There's a lot of like linear algebra involved. It's better sometimes just to have it rendered in this fashion. So one of my favorite APIs is the I know where your cat lives, right? It's actually, or sorry, one of those demonstrations of how you can infuse data, you know, with different pieces of information is this particular project. So I know where your cat lives. You can Google it. It's basically kind of the marriage between geotag data and then pictures of cats, right? So it's kind of like, I think one of the headlines for this project is that it's equally amazing and creepy. And I think that's pretty accurate. You can see here that this is a picture of a cat from Minsk, Belarus, that you don't know whether this person knew that they were going to be on the front page of I know where your cat lives, but then when they took a picture, there's some metadata stored in that image file that you can access from an API, and you can take that image data and you can attach it to geotag data and kind of connect the two, and then you can stick it on a Google map. That's what this app does. It connects these two pieces of information, and it renders it in a way that that basically makes it an interactive application, but it could be a static map. This is just kind of the design they chose. The interesting, you can hit random cat, and what you'll see is it'll just kind of cycle through a different set of images. But this is really the benefit of these API systems, is that you are able to enrich one of these systems with the other piece of information. And that's really kind of the way to think of APIs, is that this is a way of linking currently existing data with maybe data from another resource to make it that much more, just to tell a more kind of a richer story. It's going to give you a lot more. I mean, this is a perfect example of a project that you're taking pictures of your cat and giving it a context of, like, I mean, to me, I looked at this and thought, I mean, I have cats, so I'm looking at this thinking, hey, my cat does the same thing that this cat does in Russia or in Thailand. It's one of those, I wouldn't have necessarily thought that had I had I not come across this. And I mean, I look at a lot of cat pictures. So how does it work? Well, people upload images via Instagram or Flickr. Those images are tagged with some, it's called an XGIF. It's an acronym here. So it's actually an EXIF, EXIF record right down here. It's in the notes, so feel free to look at the show notes. It'll give you more of a description of what I'm showing. So that piece of information is stored in an API, and these are all images, right? So you have MP4s, JPEGs, PNGs. It's stored in the metadata. Now, a user comes along and they write a query to that image API, and they pull out anything that basically has a certain attribute, like the picture looks like a cat, right? And the metadata, which is the location, which we just talked about. Now, that information, they then combine with another API, which has GPS data, which they can use with the EXIF to basically get a latitude and longitude, which is what they will need to put the picture of the cat onto a map. Now, OpenStreetMap API is one example. There's a lot of other mapping API systems, but this is the same basic process, right? So you get an actual physical address. That physical address that needs to be fed into a system to get a latitude and longitude, because that's how we're going to map that onto a particular space. It's that process across multiple sources. All that happens, and then you get your image file, the data that is attached to it, you overlay that onto a map, and you end up at I know where your cat lives. This is obviously, there's a lot of technical work behind here, but this is the basic flow for how these work. Feel free, if there's, I always leave my slides open. If you have any questions, you can add a comment to the questions, but this is, I know that we have a limited number of students in the class, so feel free to ping me in the chat, or you can always add a comment to the slides if you have any questions about kind of how they did this. I included some links. It's a really interesting project, but we're going to do a similar process today with some existing data. We're going to pull it in from an API. We're going to parse some of the JSON so you can see how the process works. So in the last OpenRefine cleaning data workshop I gave, we kind of went through how to load data into OpenRefine. I'm going to go ahead and demo it here, but there's a hyperlink in the slides that you can use. I have OpenRefine open here. I'm going to go ahead and go into, I know this project also lives on GitHub. This is everything that's in the slides. But I'm going to go into the data folder. I'm going to go ahead and pull out the CSV file. And if you click on the CSV file, it's going to say, that it can't, but it's going to say that this is beautiful and searchable, that they can change it, but we actually want to look at the raw file because we're going to upload it. So we don't need to see it all pretty and searchable. We just want the raw file. And we're going to go into web addresses, and we're going to add here, the full hyperlink. We click next. It's going to say, this is a perfect name. We just name it US addresses. I'm a bit neurotic about having a dash there, but it recognizes it as commas, parse text. It's great. Use character. I'm actually not going to bother with anything else. It does load an extra column, which I'll just remove. Edit column, remove this column. So now I have two columns of, let's look at all 50 of, these are randomly generated addresses. And so what I wanted to show is you never get the data in a perfect kind of format. Like someone had gone through here, probably copied and pasted 2 different rows from a database, rather than it being broken apart into city, street, city, state, and zip, which would be 4 columns. They went street and then city, state, zip, right? And stuck it all together. And the thing is, this is a really common situation. It's that almost always the data are never collected in a way which you need them to analyze. So what we're going to do is we're going to go through some of the steps that we'll need to get these data clean and ready for the JSON. So we've loaded them in here. I apologize, this is going to be a little bit different view because I want to be able to switch back and forth between the slides and what you're going to be doing. So the first thing we want to do, oh, I'm sorry, is this is we want to create a full address column. And this is a common use for OpenRefine, is that you want to add a new column based on a current column. And so there's information that are crammed into, you have multiple variables stuffed in a single column. And that happens a lot. GREL is this, I think it's a Google Refine, it's now called General Refine expression language. I thought it was Google Refine expression language, but this is a very straightforward scripting language for you to be able to do a lot of these operations. So we're gonna go through an example for how to get these addresses split up. This is the GREL expression. It's also in the notes, but what we're gonna do is we're gonna go in here, select the street column. We're gonna go edit column, add column based on this column. This new column is going to be called full address. We want to store the errors because it's always kind of nice down the road. It's just kind of keeping track of anything you have to do any kind of debugging for. This, we just copy and paste it directly in there. What you can see is that it adds the value from this current column plus a comma and a space. And then it adds from the cells of city, state, and zip the value. Pretty straightforward, no syntax error. That's what we're checking right here. That's the expression. The preview looks good, so we click OK. The only thing that's kind of a bummer is that it puts it right in between the two. So we're going to go ahead and do it once again, edit column. We're going to move this column to the end. So now we have street, city, state, zip, and full address. So the full address is what we're going to be using to access our API. In the next, by the way, I have slides that obviously walk you through how to do everything. The next few slides here, I'm just going to go ahead and run through because it's going to be something that you're going to have to do on your own. I went to, and this is something to get familiar with if you're going to be using an awful lot of APIs, is you have to get what's called an API key. API key is just a random set of alphanumeric characters that give you a unique login to be able to access API data. Most of the time, they're pretty generous. People will give you a certain number of API keys for free, or they give you a certain amount of data kind of access for free. We're going to go to the MapQuest developer API key. If you click on the link in the slide, it'll take you over there. When you log in, you probably you'll log in through Google or Dropbox or Facebook or whatever the current login is. You're going to create a new key, and then on your dashboard you'll see you're automatically given a key called My Application. You can use that key. I actually have that on another project, so I created a new one called OpenRefine app. And then you click the Manage Keys, and then you can click the Approve All Keys, and it should give you like a thumbs up, just saying all these keys have been activated. Feel free to use them. This is a process that you'll kind of get used to. Every API is a little bit different. You will see that there's a big range of documentation available for every API. So we go through setting all that up. I want to go through an example API request. These are pretty similar, between the two technologies, but this is between different technologies, but this is kind of the basics. So what you end up with are the portion of the address that, of course, is written in just hypertext transfer protocol. So it's that jumbled HTTP or HTTPS :/, and then the name, the actual domain address of the API, which is almost always, it's like data or open, and then there's an API somewhere in there, .com or sometimes it's a .io. You see the name of the API, the version, usually that's the nominatum is the name of this particular API, the version, the v1. And then we want to actually access the search API. So sometimes you'll see method question mark. The PHP is just basically the call to, because MapQuest has multiple APIs, we're telling it we want to go to the search API. And then we just add some attributes about how the data need to look when they come out. So we have the format. I went ahead and put my key in here. I'll probably delete it later, but I wanted you to see, what it looks like. There is just a bunch of jumbled text there. You'll put it in quotes. Key equals your key. You put an ampersand at the end. Every component of an API request is separated, after the actual API is specified with the ampersand. So you have format, key, and then the query. And the query equals addresses, right? The addresses are stored in our current data file. So what we're going to do is we're going to go through how to access this and I'm checking the time. We're like right at 30 minutes right now. So I apologize for going a little bit over, but I feel like this is probably useful for you to see done in real time as opposed to me just going through the slides. So we have, and hopefully Mark can kind of edit this down to fit within the 30 minutes. So we have a new column name that we're going to generate here based on the address that we just created. We're going to set some attributes, and then we're going to test it. And I'm going to walk you through how to do that. So the full address, new column, we're going to go to edit columns, and it's going to be add column by fetching URLs. Oh, great. I just got the go ahead from Mark. Okay, so the new column name, this is, I think in the slides, I think I refer to it as, okay, great, MapQuest locations. So MapQuest locations is going to be what this is. Sometimes it's better to go for a long name that actually means something. We're going to limit it to just 1 second. Again, store errors because it's always helpful to come back and debug it later if you can actually see the content. So it's telling us that this is a parsing error. We have a real problem here if we're going to try and write an API request. We don't have any of the GREL language. I included the entire GREL expression here in the slides, and it's also on the GitHub page. And I'm going to go through what is going on with each of these. So GREL is incredibly straightforward. You just have to be a little bit careful about the spaces and the pluses. So if you can kind of remember back to the slide, all I'm doing is using literally the addition symbol to combine the various components of the API request. So we have the domain address, which is the open API or open.mapquestapi.com. We have the version, that specific API. The search API is really the important part there. Sometimes you'll see method equals, right, or method question mark. That question mark is really indicating kind of everything beyond that is an attribute of the data that you're requesting. Apologize, I'm getting a little drink here. So we want our data formatted into JSON. So we're going to add format equals JSON. We're going to end this with an ampersand. We're going to add our key, end it again with an ampersand. And then this is where it gets a little bit trickier. We actually are going to add the query equals with this escape function, which is the value of the cell as a URL. So what we're saying is that you're going to add for each row, you're going to add query equals that address that's in this particular column as a URL. So it's going to do its own kind of formatting for this particular address. So this top one's 77 Brockton Ave and Abington, Mass. We're going to highlight it because this is kind of the benefits of any kind of web data is that if you highlight it and hit enter, I should see a JSON. This is a JSON file. We can see that this is at that address is a Walmart. There's even an image here, right? That's showing, this is our Latin long. We can see the latitude, the attribute, the longitude, the display name. So this is telling us we are in the right place, right? So the API worked, it sent the right data there, it brought the right data back. So what we can do is, now that this is all set, we can hit OK. Now, this is the part that I will probably end up resorting to the slides. It will take some time. You'll see here it's moving pretty slowly. This is only 234 rows. We could limit it and get a little bit faster, but it's running through every single one of these columns. And you can also, just let you know, there's a whole article you can see how to kind of recalibrate OpenRefine's memory usage to get this to run a little bit faster. But I'm just going to let that run in the background. We're already at 1%. It's probably moving slower because I'm on video also. But what ends up happening, I even have a note in here, takes a long time for it to get done. But as long as it's moving forward, you know that it's giving you the JSON format. So back to the presentation here. We'll see if that runs in the background. This is what you'll see. The MapQuest location gives you a column that includes all the information that we just saw up in our web browser. Now it's stored in this particular format, which is a little bit hard to read, but you can see that it contains information like the latitude, the longitude, the original address. That's always a big one to check. You can see the 777 Brockton Avenue, Abington, right? So it's clearly linked to the correct location. We want to make sure and verify that with a couple of different columns. I always just kind of scan through and make sure that I'm visually assessing that these are correct. What I want to do now is parse this JSON data because it's not necessarily useful for me in this format. It's all in there, which is really helpful, but I can't use it as well if I want to, map it onto, Google Maps, or I want to take it into like Tableau, or if I want to take it into R or Studio, or make some kind of presentation with it. So I need to get the latitude and longitude columns out of that JSON. And this is how I'm going to do it. I'm going to go into the same edit field. I'm going to go edit column, add column based on this column. It's the same one we did when we created the original full address. I'm going to go in and specify this is the latitude column. I'm going to store the error once again. And this is actually going to be value.parseJSON, which is a function in GREL that will give us the latitude portion of the JSON. And you can see that by hitting parse JSON, the open and close brackets, and then the 0 with .lat, it's going to look through here and find the 42.096. Unfortunately, I think it's cut off. You're going to have to look at. I think I have to look at it in the other. I wish that the image was larger on my screen, but this is. You can see the lat, right? So it identifies the string and then gives you the number. So you can see it again in the other slide when we do it for longitude. Once again, we put longitude. We just change this value.parseJSON, the same exact syntax, but instead of lat, we use lon. And then if we look, I think it's still hidden on the other side. But you'll see it'll when you can look at the entire JSON, you'll see that it's in quotes lon colon and then a number. Same thing with the latitude. So you can see how the functions work. They actually identify the text string and return the number. So that's what I mean by the JSON and the XML. They're containing attributes about a particular piece of data that we can then use to kind of parse and get those attributes out. When we get to both of the columns, so now both of the columns have been created. We hit OK on both of them. And let me see how close this is. Hopefully, we're still at 14%. So when they're both in their, when it's in its completed format and you have both of the columns that have been added to your particular, I feel bad canceling this, but we're just going to have to, because we can go back to there we go. My finished version of it. So here's what it looks like. I'm sorry you didn't get to sit and watch the JSON's parts. This is what it looks like when it's all done. Here we have the full data set. We kept the JSON, but if we wanted to export just the latitude, longitude, and the full address for mapping, we can now do that. We see that we just get 2 clean numbers on both of them. Just to let you know, not every single address matched, but that's possible, right? So somebody put it in an address that for whatever reason there was no return on this, right? So some data APIs have more information than others. You're just going to have to kind of play around with which ones kind of best fit your needs. A lot of times the documentation will really kind of key in if it's the best use of if it's the best application for the data you have. One of the things that I also recommend doing when you can. We used a fair amount of GREL in this particular example. So if you go to the undo and redo, you can see that there were an awful lot of steps here. Here we have remove column. Maybe we keep that. But really, I think that the important part of this analysis was this guy. So create this, so extract, right? Remove column, create new column, create this new, create our new API-based data, enrich this. So the thing is, you can go through and you can choose which of these you want, which steps you want to include and which steps you don't. And then what you can do is you can store that as a JSON file. So what I could do, right, because if I get all the way to the end of this, where I have this nice, so this is the full complete data set. You can see that there's 16 steps. That's kind of a lot to go through. If I go to extract, everything is there. Maybe I don't want all of it. I can select or unselect some of them, but this is all highlightable. So you can just go Control All or Command All to get everything in there. And so what I've done actually is I've on the GitHub folder, you'll see that I have some JSON that's basically just it's the instructions for what I just did in creating this particular data set. So this US address is JSON. This contains all the information that I would need. You can see, here's the expression, the value, right? For me to create that new full address, column name, right? And then I moved it around. And then I added this new API set of data. And so this is an instructions sheet that I can copy and paste directly out of here. And I can go back and OpenRefine. And so if I came into this project again, rather than having to remember all the commands to type and everything else, I can keep that script. I can come back to where this data was when I first started, right here. And I can basically just click apply. I can copy. Now it's going to do the exact same process. So it's great if you use a lot of APIs. This is a really useful thing because it can be a little bit tricky to get that URL written once. But one of the benefits is that once it's done, it's only it's only a couple of copy and paste away from being able to repeat the process. So this has been kind of a whirlwind and a lot of stuff. So definitely go back through and read through the slides and the notes. I included an awful lot of links and examples. This particular project is all on GitHub, so you can scroll through each section here. I'll include the link is obviously included also in the for the slides are here. These are openly editable, and then I included there's a bunch of great OpenRefine resources on GitHub, and then also from John Little has a great from Duke. He has a great pragmatic datafication workshop on slide and his slides and workbook on some different API uses. With OpenRefine. We're about 12 minutes over now, so I want to make sure that I'm bringing it to a halt. If there are any questions, please feel free to email or reach out to me. I'm always available either on GitHub or on email or Twitter if you have any questions. I hope this was useful. I'm going to hand the mic back over to Mark.